My dear students, after a long gap, I am going to continue my videos under the topic Differential Equations in 12th Standard Mathematics State Board Syllabus. In my previous video, I have discussed about the order and degree of a differential equation and also formation of differential equations. From the given equation, they are forming the differential equations. These two concepts we have seen in our previous videos. So in this video, I am going to solve the differential equations under various types. Differential equations are going to be solved in our coming videos. So at first, solutions of first order and first degree differential equations. That is the topic now. Solutions of first order and first degree differential equations. That too, type 1 is variables separable. Variables separable means a differential equation sin x dy plus cos y dx equal to 0. Like that, you can find a differential equation. So in this differential equation, you keep sin x and dy equal to minus cos y and d. You just split these two, this single equation into two sides. You bring x terms on one side and y terms to the other side. That is called variables separable. The variables x and y variables are separated, and then we have to solve the differential equation. So sin x dy, you keep dy dx in the numerator itself. You should not bring dy and dx to the denominator here. You keep dy and dx as it is in the numerator only. So you bring this cos y. If you bring it to the left hand side, this cos y becomes 1 by cos y dy is equal to minus 1 by sin x dx. So that's why the variables are separated. So y dy terms and x dx terms are separated. That's why this type is called variables separable. We are separating y terms and x terms in one side. After that, you have to integrate. You can get the solution of the differential equation. 1 by sin y is cos y. You can say this is secant y. 1 by cos y, you can write it as secant y. Equal to minus integral 1 by sin x is cosecant x dx. Integral secant y. Integral secant x is, you know that, log secant x plus tan x. You know the formula for integral secant x is log secant x plus tan x. So integral secant y is log secant y plus tan y. Integral secant y is log of secant y plus tan y is equal to minus integral cosecant x is minus log cosecant x plus cot x. So the integral cosecant x is minus log cosecant x plus cot x only plus an integrating constant c. We will get an integrating constant. So like that. So log of secant y plus tan y plus minus into minus plus log of secant x plus cot x plus c, or otherwise you bring all the terms to the left hand side. Log of secant y plus tan y, this minus the minus plus, if you bring it to the left hand side, is minus log of cosecant x plus cot x equal to, you consider constant c by log c. It's again a constant. You can consider every term is in logarithm term, therefore the constant is also you can consider as a log constant log c or log capital C. So this is the solution of the differential equation, general solution. From that you can write it as log m minus log n is log m by n. Log m by n. From this you can write it this step. Log m minus log n is log m by n, that is log of secant y plus tan y by cosecant x plus cot x equal to log c. So from this step, you apply log m by log n formula and convert the solution into a simpler form. So this is one type of differential equation. This type is called variable separable. So variables to be separated. X type x and dx one side and y and dy you bring it to one side, and after that you have to integrate. You will get the general solution. This solution is called the general solution of the differential equation. This is what we have to see in this first step. Okay. Now we will solve the problems one by one in this type. Find the general solution of the differential equation. The problem is solve or find the general solution. Solve the equation 1 plus x square into dy by dx. 1 plus x square to dy by dx equal to 1 plus y square. This is the problem. You have to solve this equation or find the general solution of this equation. 1 plus x square dy by dx equal to 1 plus y square. Here you have to separate the variables. The 1 plus x square dx, if you bring it to the right hand side, it becomes dx by 1 plus x square, and this becomes dy by 1 plus y square. Now variables are separated. X dx terms, y dy terms are separated. You bring this 1 by 1, right hand side 1 by 1 plus y square to the left hand side, it becomes denominator dy by 1 plus x square, and this is dx, denominator dx goes to the numerator, and 1 by 1 plus x square comes in the denominator. So after separating this, you have to integrate 1 by 1 plus y square dy equal to integral 1 by 1 plus x square dx. You know integral of 1 by 1 plus y square is tan inverse y. You know the formula? It is tan inverse y. Integral 1 by 1 plus x square is tan inverse x plus one integrating constant c. Tan inverse 1 by 1 plus x square integration is tan inverse y, and 1 by 1 plus x square integral is tan inverse x. And you bring tan inverse x also to the left hand side. It is tan inverse y minus tan inverse x equal to c. You know tan inverse y minus tan inverse x, inverse trigonometric function. The formula tan inverse y minus tan inverse x is, you know that tan inverse of y minus x by 1 plus xy. This is the formula for tan inverse y minus tan inverse x is tan inverse of y minus x by 1 plus xy equal to c. And again this is y minus x by 1 plus xy equal to tan c. This tan inverse becomes tan function. That is, you get y minus x by 1 plus xy. Y minus x by 1 plus xy equal to tan inverse. If you operating both sides by tan, you will get tan inverse tan is tan c. Tan inverse becomes tan c. Now you consider this tan c by another constant a. So this is a constant, therefore I consider the constant by a. Y minus x by 1 plus xy equal to a, or otherwise y minus x equal to a into 1 plus xy. This is the general solution of the differential equation. This is the solution of the differential equation. Answer. That's all. That's all about the problem. This is the solution, general solution of this differential equation. Next, we will solve another problem. Particular solution, how to find out the particular solution if the conditions of x and y is given. That is another problem we will solve. find the particular solution of the given differential equation. That is our next problem. Find the particular solution. That is the next problem. Find the particular solution of the differential equation. Find the particular solution of the differential equation. 1 plus x cube into dy, 1 plus x cube into dy minus x square y dx equal to 0. 1 plus x cube into dy minus x square y into dx equal to 0 satisfying the condition y of 1 equal to 2. Satisfying the condition y of 1 equal to 2. So find the particular solution under the condition y of 1 equal to 2. That means if x equal to 1, y equal to 2. That is the condition. If x equal to 1, y equal to 2. Under this condition, what is the particular solution? First we have to find out the general solution by variable separable method. This is 1 plus x cube into dy equal to this minus x square terms becomes plus x square y dx if you bring it to the right hand side. Next, x square by 1 plus x cube in the denominator term you will get, if you bring it to this 1 plus x cube to the left hand side, it becomes the denominator. X square by 1 plus x cube into dx equal to, if you bring this y to the left hand side, it becomes 1 by y dy. That's all. The variables are separated, y terms, x terms are separated. Now you integrate. 1 by y, integral 1 by y is log y equal to, this is integral 1 by 1 plus x square by 1 plus x cube. You integrate this, you substitute 1 plus x cube equal to t. So 3x square dx equal to dt. So x square dx equal to 1 by 3 into dt. So in the numerator x square dx is 1 by 3 into dt, therefore this becomes 1 by 3 into dt by 1 plus x cube is t. This integral, after substitution, you will get this 1 by 3 into integral dt by t. By giving a substitution for 1 plus x cube equal to t, we get this by this way. So it's again equal to 1 by 3 into the integral of 1 by t dt is log t. Okay, plus C1 we can say, it's a constant. It is here, you get log y. Okay, multiply throughout by 3, you will get 3 log y equal to log t plus 3C1. Now this is 3 log y is log y cube minus log t. You bring this log t to the left hand side, it becomes minus log t equal to 3C1. I can write it by log c. Log capital C. It's a constant. 3C1 is again a constant log c. You will consider as, because the left hand side is also, you will get the terms in logarithm. Therefore, constant is also you can consider by logarithmic term. So you replace t by 1 plus x cube. That is log of y cube minus log of 1 plus x cube equal to log c. Okay. This is again log m minus log n is log m by n. So this term becomes log of y cube by 1 plus x cube equal to log c. Log m minus log n is log n by n. Log of y cube by 1 plus x cube equal to log c. Eliminating logarithm on both sides by using exponentiation. Raising the power of exponential on both sides, e power log is 1. Therefore, raising the exponential term in both sides, The logarithm is eliminated and you will get y cube by 1 plus x cube equal to c. That is y cube equal to c into 1 plus x cube. Y cube equal to c into 1 plus x cube. This is the general solution. For the particular solution, you have to substitute x equal to 1 and y equal to 2. Put x equal to 1, y equal to 2. 2 cube equal to c into 1 plus x equal to 1. 1 cube. That is 1 cube is 1. 1 plus 1 is 2. 2c equal to 8. So c equal to a by 2 is 4. You substitute for c in the general solution. Therefore, the particular solution is y cube equal to c is 4. 4 times of 1 plus x cube. That is the required answer. Y cube equal to 4 times of y cube equal to 4 times of 1 plus x cube is the answer for this, the particular solution for this equation. This is the general solution of this differential equation. In this general solution, you apply the conditions for x equal to 1 and y equal to 2. You will get the value of c is 4. After substituting value of c, you will get the required answer. That's all about the problem. This is the particular solution. Finding from the general solution, we have determined the particular solution. Next, we will go to the exercise 10.5 in your textbook and we will solve the problems in the exercise. Exercise 10.5. In the exercise 10.5, the problems are asked to solve the equations. That is, we have to find out the general solution of the given equations. That's our problem. Exercise 10.5. First problem. In the problem number 4, fourth problem, the first subdivision, solve dy by dx equal to root of 1 minus y square by 1 minus x square. Root of 1 minus y square by 1 minus x square. So you rewrite this, you have to separate the variables. This is root of 1 minus y square by root of 1 minus x square. You split this into 2, numerator denominator, and you take that dx to right hand side. This is 1 by root of 1 minus x square into dx, and bring the root of 1 minus square left hand side, becomes 1 by root of 1 minus y square dy. So variables are separated and we have to integrate. Integrating both sides, integral 1 by root of 1 minus y square dy equal to integral 1 by root of 1 minus x square dx. Integral 1 by root of 1 minus y square is sin inverse y equal to integral 1 by root of 1 minus x square is sin inverse x plus integrating order c. So this is again, you can write it as sin inverse y minus sin inverse x equal to c. That is the solution for the general solution for the differential equation. Okay, that's all about this problem. And I will solve one more problem. Second problem also in the fourth subdivision, it's also a simple problem. C. Second one, second problem in the exercise is y dx, solve y dx plus 1 plus x square, y dx plus 1 plus x square into tan inverse x dy equal to 0. That's all about the problem. Y dx equal to minus of 1 plus x square into tan inverse x dy. You split this 2 into left hand side and right hand side because we are going to separate the variables. So y, if you bring this y to the left hand side, it becomes 1 by y, and you bring these two terms, tan inverse x into 1 plus x square is 1 by this, it becomes 1 by 1 plus x square into tan inverse x. 1 by 1 plus x square into tan inverse x dx equal to minus y becomes 1 by y dy. That's all. So the variables are separated. This 1 plus x square tan inverse x, if you bring it to the left hand side, it becomes 1 by 1 plus x square tan inverse x dx, and that is minus 1 by y dy. Now you integrate both sides. This is denominator integration, derivative of tan inverse x is 1 by 1 plus x square. So you write it by 1 by 1 plus x square. You 1 by 1 plus x square to the numerator, and you keep it tan inverse x in the denominator, minus integral 1 by y dy. Why I write like this is derivative of the denominator is in the numerator. Derivative of tan inverse x is 1 by 1 plus x square. So f dash of x in the f dash of x by f of x dx is, you know, the integral value is log of the denominator. If you find a term in the derivative of the denominator term in the numerator, the derivative of the denominator term in the numerator, you will get the value of the integration is log of the denominator. Log of tan inverse x is equal to minus log y. You consider this as my log c. Constant also you can write it as log c because every term is logarithm. Therefore this is log y. You bring this minus log y plus log of tan inverse x equal to log c. This it becomes log y plus log m is log m plus log n is log mn. Therefore you get log of y into tan inverse x. Log m plus log n is log mn equal to log c. Log y plus log tan inverse x is log of y into tan inverse x is log c. Eliminating logarithm on both sides, you will get y into tan inverse x equal to c. This is the answer for the given problem. General solution is this: y into tan inverse x equal to a constant c. That's all about the problem 2. So I will stop here, and we will continue the remaining problems in the next video. Thank you.